Hello friends, good morning everybody. Welcome to the lecture number 2 of Pneumatics. In today's online lecture, we will study the Pneumatics part 2. So I am Professor Shivanand Talwar, working as an assistant professor in Mechanical Engineering Department. Today we will discuss about the mainly that is components of pneumatic system. The component of pneumatic system, we will study the types of filters, then pressure regulator, lubricators, mufflers, dryers, and in addition to this, we will also cover the topic of air receiver, then compressed air distribution system, after coolers. So some other components which are used in the pneumatic system that we will study. Okay, so course outcome for this lecture is to illustrate the components, control valves, and circuits of a pneumatic system. Learning outcome for today's session is that we have to explain, after studying, you have to explain the various stages of air preparation, how the air is prepared. Then the list the various functions of after cooler, then describe the various types of air dryers used in pneumatic industry, then size the air receiver, explain the FRL unit, that is filter, regulator, and lubricator. So first we will study about the air filter, air preparation. So in the air preparation, it occurs in the 4 stages. Uh, the first stage is that it consists of an air intake system. So initially here what will happen, the air is uh, air we are getting the air from the atmospheric air. Okay, so the that is our first stage, that is the air intake system. So initially air has to come. We have to locate that air where the air we will be getting. Then second stage, this stage consists of the compressors. Then compressors which drives the control, compressor which drives the control. Then intercooling, if intercooling required for the compressor, that is compressor cooling. Then waste heat recovery, and air inlet filtration. Okay, so what are the air will be coming uh, to the compressor, again there we will keep the filter, pre-filter. Okay, then stage 3 includes the conditioning equipments such as air receivers, then after coolers, separators, then traps. Okay, so also frequency called drain traps, that is drain traps will be there. What are the water vapor or the condensate is there, that has to be drained. Then pre-filters and air dryers. So mainly in this stage 3, what are the components we are using, equipments, that will be air receiver, air cooler, then air dryers. Okay, filter it will be in every stage, that is pre-filter is we will say. Then stage 4 it consists of the air distribution subsystem. Okay, it includes the main trunk lines. Okay, so here mainly we will using the additional filters, then air hoses, then possible supplement air conditioning equipment, connectors, okay, and pressure regulators and lubricator. So from this in this stage normally we will be using the filter, okay, then regulator and lubricator. With in addition to this, because this filter regulator unit, this will be directly connected to the air distribution systems. So again, that hoses, walls, and all will come. Okay, so as you can see from this diagram, the different stages in these stages, how that it is divided. So stage 1, it is the air intake system. Okay, so air will be available, that is ambient air. So that will be available. Okay, so that will go to the intake filter for the air compressor. So in the second stage, we are having the air compressor. So compressed air, it will compress the air. Okay, so again here we are using the safety valve is always necessary. So this the air, it will travel to the after cooler. Okay, in the after cooler, then from the after cooler, air will go to the air receiver. Air receiver again, whatever the condensate is there, so that water trap is kept at the bottom. So from here, the that can be passed. Okay, so again, the safety valve is used in the air receiver. It is very important. Safety valve, it is the for the pressure regulation. Okay, to control the pressure. Then mainly, if you see the, we know that in the stage 3, air receiver is there, air dryer is there, okay, and after cooler is there. So these three are the so we will discuss this in the later slides. What is after cooler, then what is air receiver, and what is air dryer and all. Okay, then in the stage 4, it consists of the filter will be there. Okay, it will be having the FRL unit, FRL stage 4. So that is filter, regulator, and lubricator. Okay, so from here, the dry compressed from the FRL unit, the dry compressed air will be sent to the distribution system. So distribution system, the air will go and it will go to the control valves, then to the actuator, then the work is done in the system. So in this way, the air is prepared. Whatever the compressed air is there, it is prepared. So you can see it is a lengthy process. Okay, but if you want the good quality of air, then we have to go through this uh, process. Okay, so let us discuss in detail about these stages. So stage 1, it is about the air intake. Air intake, stage 1 is about the air intake. So first here we require the location. What is the location? Though, so that the intake for the compressor will be located either outdoors or indoors. So whichever provides the better quality. So we have to choose the location such that the whatever the ambient air is there, it should be easily available. Whether it is indoor or outdoor. Then we have to see the intake temperature, because the density of air, it varies inversely proportional with its temperature. So an increase in delivery approximately 1% is gained for the minus 20 degrees Celsius reduction of intake temperature. So again, we should not keep the location of the compressor where the temperature is very high. Okay, so again, that intake temperature, it also matters for the generation of the compressed air. Then again, intake pipe material, we have to see the intake pipe material. So inside of the intake piping must be smooth. That piping what we are using, it must be smooth, and it should not be subjected to rusting or oxidation. So we have to select the next is the critical pipe length. We have the pipe length, it should be very critical. Okay, so these pipe length, they are the function of the air temperature and the speed of the compression in revolution per minute. Okay, then intake air filter we will use in the stage 1. That is the selection of the filter type. It will be based on whether the compressor, whether it is lubricated or non-lubricated, and on the quality of the ambient air. Quality of the ambient air, the intake air filter varies. Okay, in the stage 2, air is compressed using the compressor. Already we have studied about the compressor, different types of compressor, that is reciprocating type compressor and rotary vane type compressor. So in the pneumatics, mainly we will be using the positive displacement type compressors. Okay, so how the air is generated, that we know, that we have studied in the compressor part. So stage 3, what happens in this, the outlet temperature of the compressor is reduced. So the contaminants, solid contaminants, they are large, that is they are of the 100 micron. So this has to be removed. So again, so this has to be removed. For that purpose, we are using the after cooler. Okay, then we are using the dryer. Okay, and the air receiver. Okay. Then in the stage 4, so in the stage 4, what happens, the moisture and the again the fine dirt particles, they are removed. So in this stage, what we will do initially, we will that cooled air, it will be passed through the filter. Okay, then from the filter, it will be passed to the lubricator, that the pressure is regulated, and some moisture is added to the air in the lubrication, in the air lubrication. So that combinedly we call it as the filter, regulator, and lubricator. Okay, so this was about the stages of various stages of air preparation. So now we will start the topic of the after cooler. Okay, after cooler. So after cooler again, they are the heat exchangers for cooling the discharge from an air compressor. Okay, they after cooler is nothing but an heat exchanger. Okay, they after cooler they will use either water or air. So they are the effective means of removing the moisture from the compressed air. So after coolers, they controls the amount of water vapor in the form of the compressed air system by condensing the water vapor into liquid form. So in a distribution, you can see in a distribution or the process manufacturing system, liquid water, they can cause significant damage to the equipment that uses compressed air. So when we are using the compressed air in the distribution system, so that may cause the damage. Okay, so if we are keeping the after cooler, okay, so that pneumatic or the air handling devices may be easily handled in the manufacturing system. So again, why we are using the after cooler? Because at the time of the compressed air generation in the compressor, if we are using the cooling process, then the output pressure will be reduced. Okay, so that's why we are using the after cooler. So in this after cooler, about the 75% of the moisture can be removed. So in some of the cases, it may go up to 80% also. So, and we are using the moisture separator, which is installed at the discharge of the after cooler. So it removes the most of the liquid moisture and solids from the compressed air. So normally we are having the two types of after cooler. They are air cooled water cooler. Okay, so air cooled after cooler and water cooled. So this diagram, it shows about the air cooled. So air cooled, what happens? The hot compressed air, it will enter inside. Okay, enter inside, and cooled compressor will come outside. And one moisture drain is there. Whatever the moisture is collected, it will be passed through this moisture drain. Okay. So similarly, we are having the that is the water cooled uh, after cooler, water cooled after cooler. So a water cooled after cooler, it is like this shell and tube type heat exchanger, shell and tube type heat exchanger. So immediately in the tube, the tube air will be passing, and in the another tube the water will be passing. So due to that, the cooling will take place. Okay. So then second component we will discuss, it is the dryer. So dryer, we know that dryer, it is the dryer function is to lower the dew point of the compressed air. So by removing the moisture from it, so dryer again, it lowers the dew point of the compressed air. So for the simpler application, we to remove the excess humidity, so we need the after cooler and receiver and a filter with the condensate trap. Okay. Then to get the high quality compressed air, additional means of dehydration must be provided by using the dryer. Okay. So first, we know that in the stage of air preparation. So after the compressed air from the compressor, it will go to the air receiver. So where it is stored, air is stored. From there, it will go to the after cooler. Okay, then again it will go to the dryer. Okay, so when the cooling is done again, so after that we have to dry that air. So that purpose we will use the dryer. So generally there are four types of dryers. That is absorption type dryer, then adsorption type dryer, then refrigeration type dryer, and the membrane type dryer. Okay, so let us see the first type, that is the absorption type dryer. So in the absorption type dryer, we are using the pure chemical process. Okay, we are using the pure chemical process. The here the moisture in the compressed air forms a compound with the drying agents. With drying agent, like we will be using the pentoxide in the tank. So the drying agent is phosphoric pentoxide. Okay, so this causes the drying agent to break down. So drying agent will get break down. So it is then discharged, the drying agent, it is discharged in the form of the fluid at the uh, tank. Okay, oil vapor and oil particles are also separated in the absorption dryer. Okay, large quantities of oil can have the effect on the efficiency of the dryer. So what we can say, if we see the diagram, if we see the diagram, what happens? So let us see the diagram of this absorption type dryer. So here what happens, the moisture air inlet. So from here the uh, that is air will go through the inside of this dryer. Okay. Then uh, here we are having the flux. Okay, that is the condensate will be there. The condensate we are using the phosphoric pentoxide. Okay, so that phosphoric pentoxide it will break down, and the dry air it will then come outside of the dryer. So what are the liquid or solid condensate are there? It will go through this condensate drain. Okay, so that is a main purpose of our is that we have to get the dry air at the outlet. Okay, so mainly it is the process is by the absorption of the chemical agent. So chemical agent like phosphoric pentoxide is absorbing. Then second type is the adsorption type. Yeah, so in the adsorption type, what happens? So here the moisture removal is moisture removal on the porous surface. It is done by the granular materials. Okay. So here what happens? The gaseous molecules are attracted to the solid surfaces by the van der Waals forces, and this causes the adsorption. So the degree of attraction or the adsorption depends on the property of gas molecules and desiccant. So mainly the desiccant it will adsorb. So because the what are the moisture is there that will come and they get attached to this desiccant. Okay, so most commonly desiccants they are the alumni molecular sieves and silica gels. So this is the diagram of the adsorption type compressor. Okay, so here the air from the compressor it will go to the two. There are two adsorber are there, adsorber 1 and adsorber 2. One will act for the drying purpose. Okay, one is acting for the drying purpose, that is the hot air, that air is there, that compressed air it will be drying. And second adsorber 2 it is used for the regeneration. It is used for the regeneration. Okay. So in this way, this adsorption type dryer will work. So again, the air heater is provided. Air heater will it will dry the air. Then third type is the refrigeration type dryer. So in this type of dryer, we are having the again two heat exchangers are there. Two heat exchanger. So one that is the stage one, and one is the refrigerating unit. So that is the stage two. So that is here. It is the purpose is to reduce the temperature of the compressed air. Okay. So the what are the incoming and incoming, that is warm and humid air. It is passed through air to air heat exchanger. It is first passed through the air to air heat exchanger. So that is the first one, heat exchanger one. Okay, and then the air is passed through the refrigerating unit to reduce the temperature of the compressed air as low as the +2 degree Celsius. Okay. So the drying method is based on the principle that if the compressed air is cooled to a temperature below the dew point, so the condensation will occur and water is precipitated. So we are here the compression is done by the below the below the dew point, and after the compression, what will happen? What the water left is there. Okay, so it will be drained out. Okay, so here we can see the moisture air is there. It will get inside from this side. Okay, moisture air is inside, so it will go to the heat exchanger 2. and then it will go to the heat exchanger 1. So this here it is we are using the refrigerant compressor, sorry, and heat exchanger 2, it is the air to air heat exchanger. Okay, then here we are having the moist separator. Okay, so whatever the moisture is there left out, that water will be drained out. Okay, then from here the air will go to the heat exchanger 2. Okay, then the dry air will come out. So then fourth type is the membrane type dryer. So here we are having the 3 stages. That is the first stage. It contains a filter. First, the air has to go through the filter. So it will remove the water and the contaminants down, which is the size of 5 micron. Up to 5 micron, the size of the 5 micron, the material will be trapped. So the filter will remove oil and submicron particle up to 0.01 micron. That is the oil contaminants. So it can be reduced up to 0.01 micron. So the membrane mode, it removes the remaining moisture in the vapor form. So in this 3 stage, the membrane dryer will act. So here we can see air it is getting inside into the membrane dryer. Okay, so we can see the membrane here. Membranes are there. Membranes, that is fiber material will be there. Okay, so due to the pressure difference between inside of the air and the inside of the membrane and outside, what will happen at the outlet? We will get the dry air, and the dry air, whatever the dry air will again it will return back. So that is, we call it as the cover gas feed. Okay, so whatever the moisture is there, moisture left is there, it will be get discharged from here, from the moisture discharge. So mainly here the principle is that due to the membrane. So inside the membrane, the air will be passing, and due to the pressure difference, the air which is coming out of the dryer we will get the dry air output. Okay. So next we will see the next component, that is the air receiver. Okay. So air receiver, they provide a larger system capacity, which increases the cycle time of compressor control system. Okay, so air receiver purpose is that if only if you are using compressor, to continuously the compressor will be running. Okay, if we use the receiver, so that there we can store the compressed air. Okay, so if we store the compressed air, that time what will happen? The cycle time of compressor will be increased. The receiver also dampens the pulsation from reciprocating compressors. So it acts as a reservoir to prevent excessively temperature drop during the sudden short-term demand, and can be used to smooth airflow through dryers, separator, and other air conditioning device. So that only it can also act as in the it dampens the pulsations from the reciprocating compressor. Okay, that is that vibration is released. Then that we can also have the pressure drop. Okay, it can that is, it will prevent the pressure drop. The air entering the receiver is reduced in velocity. Okay, so in the receiver the velocity is reduced and it is cooled, and we can also, some of the moisture, they may also condensate and fall to the bottom of the river, and from there it will be sent to the outside. Okay, so in this receiver they can reduce the amount of moisture which must be removed by the drying stage. Okay, if further moisture is left out, so that can be removed by the drying stage. So the receiver is also always equipped with the pressure relief valve. So we require the pressure relief valve because if in the air receiver, if the pressure is exceeding, so if the excess pressure is there, that time what we can do with the help of the pressure relief valve, we can release that excess pressure. So let us see the diagram of the air receiver. Okay. So in the air receiver, what happens? The compressed air is coming from the compressor. Okay. Here we are getting the compressed air. So then it will get inside to the air receiver. Okay. So here it starts, the air will start storing. Okay. So we should have the pressure and temperature. Yes. So pressure, we have to check the pressure. Okay. It will pressure device and temperature device. So temperature also is very important. Okay. Then safety valve. Safety valve is nothing but the pressure relief valve. Okay. Then the manhole is there. The manhole, that is removable access cover for the easy maintenance and all. So drain cock is provided here. So what are the condensates are there? Okay. So liquid condensate in the water vapor form. So it will be passed through this drain valve. Okay. So then whenever the requirement of the pressure is there, whenever the requirement of the pressure is there, that time the air can be passed through this discharge port. Okay. These are the components of the air receiver. So the sizing of the air receiver is very important. Okay. So if we will consider the three cases. So when no air is supplied to the receiver. Okay. When no air is supplied to the receiver during the time interval. So we can calculate the receiver size VR. We can calculate the receiver size VR. So VR is equal to 101 T QR divided by P max minus P minimum. So VR is receiver size, that will be in terms of meter cube. 101 T. T is the time that receiver can supply required amount of air, that is in minute. Then P max. P max is the maximum pressure level, kilopascal, and P minimum is the minimum pressure level, which is in kilopascal. Okay. This we will consider this case 2. In case 2, air is supplied to the receiver during the time interval in which air is being drawn off. Okay. So air is being drawn off. So here the receiver size will be equal to 101 T QR minus QC. QR we know, QR is the consumption rate of the pneumatic system. It is in meter cube per minute. QC, it will be the outlet flow rate of the pneumatic system. Okay. QC is the outlet flow of the pneumatic system. Okay. So in the case 3, if we consider for the compressor with offloading and loading regulation. Okay. Offloading and rolling regulation. So that time receiver size VR will be equal to 0.25 TR into QFAD. Okay. Divided by F max into P max minus P minimum into TC. Okay. So here TR is the temperature of the compressed air in receiver. Okay. So this is in case of the loading, when loading the regulation. Okay. In the working condition. So TC is the maximum ambient temperature. Okay. TR is the compressed air in, that is the temperature of compressed air in receiver. QFAD, it is the compressor free air delivery. Okay. Compressor free air delivery, it is in liter per second. P max, it is the maximum pressure level, and P minimum, it is the minimum pressure level. So here it is in terms of bar, and F max is the loading friction frequency. So usually one cycle every 30 seconds. For one cycle, it takes every 30 seconds. So this was about the air receiver. Okay. What we have studied till now, we have discussed till now about the air compress, that is the air generation. Then air generation is nothing but the air preparation, then after cooler, then dryer, different types of dryer, and the air receiver, then the different size of the air receiver. Okay, so in the lecture number 2, part 2, we will cover the